Hello, I am recording this video today to give an introduction into Neo4j and help get started on querying the database, adding new data, and exploring this data in Bloom. The first thing we're going to want to do is pull up Neo4j AuraDB, which is a cloud-based version of Neo4j. So if you search in Google for Neo4j Aura and click the first result here, it will bring you to this page, and you can click this button to start free. Click New Instance. We're going to create a free instance here, and let's go ahead and start with the Movies database, and click Create Instance. Now is a good time to go get a cup of coffee, because setting up your new instance will take a few minutes. Alright, and then after a few minutes you can see here that the instance is running. I should also mention you can download a free version of Neo4j onto your local computer. So just add your data or your information here and click Download Neo4j now, and it will install a local database to your computer. So going back here, let's click the Explore button. That's going to open up Neo4j Bloom. And if we come back here and click Query, that's going to open up the Neo4j browser. So similar to how you would query a database in SQL with SQL, this would be a way to query the database directly from the development environment. So click Connect. Up here you can see the available databases. Okay, and if you click up here you can see the databases that are available. So right now we just have the one database called Neo4j, and we have different nodes and relationships. So a node is just a dot on the screen. So if you click this button here, Movie, it essentially runs a top select star from database limit to 25, similar to SQL. So I'll go over this syntax in a second. This is the query that just ran, and it says, match all the nodes that are of type movie and return everything but limit it to 25. So I can click this button here and expand it. You can see the different movies. When you click on the matrix, you can see the matrix, and then you can see properties about the node. So Neo4j is a NoSQL database, so similar to like MongoDB, other things like that. But it's a subtype of NoSQL database called a graph database. And where it really shines is analyzing the relationships between the nodes. So I'll show you more of that in a second. If you click this button here, it will expand to show all the different relationships to that one node. So here we can see Keanu Reeves acted in the Matrix, and when you click on Keanu Reeves, you can see information about Keanu Reeves when he was born, for example. So this is a small, simple database, but you could imagine you could have all sorts of information about Keanu Reeves and all the different connections that Keanu Reeves has, right? So if you expand him here, you can see, okay, he acted in The Matrix Reloaded, The Matrix Revolutions, and it quickly expands your analysis here. So let me exit out of this. So that's just if you click on the movie. If you click on the person, similar thing. It's going to match the nodes where the type is a person and return 25 of them. Expand it here, zoom in, and you can see some different people that are in the database. All right, so let's write a simple query to ask a simple question of how many different people acted in the movie The Matrix. Okay, so I'm going to say match, because match is essentially the same as select in a SQL query. So you always start with match. So I'm going to say match, and then anything in parentheses indicates a node. So this is a node. Any dot on the screen is a node. So I'm going to say match m movie, right? So it's a variable called m. The variable type is movie, which is over here. That's the node label. And then press Shift Enter to go down to the next line and say where the m dot name, because this is the movie name, equals the matrix. And we're just going to return that node for now, because we will write the group statement in a second, but we just want to make sure that this query runs successfully. So it looks like I named the matrix wrong. Okay, and the reason I named it wrong is because the property is not name, it's actually title. So we see here under movie, the title is the matrix. So I'm going to change this to title and hit Control Enter to run it. And you can either return information as JSON or a graph. So here's the graph. But while we're on the topic of returning things in different ways, you can return relational data like an Excel sheet if you indicate what to return. So I'm going to say return m.title as title and m.released as released, and this is going to return this information in a relational format. So I'm going to press Control Enter, and here you can see columns and rows like we're used to. Now if you just want to return the node, you just say the variable for the node. So return m, and that creates this dot. All right. So next, we want to know how many different people acted in the matrix. So we can see here the answer is 1, 2, 3, 4, 5, 6, 7, 8 for this simplistic example. And actually, now that I'm looking at it more closely, these are the acted in relationships. So we're going to specify acted in and not directed. So how many people acted in the matrix? So to figure out this query, go up to the top here and press the up arrow, and that returns the most recent query that you wrote. If you hold down Control and press up, you can see all the different queries you've run. Okay, so we're just going to press it one time, and we're going to get the query that pulls back this result. And now we're going to traverse the edges here so that we can count the number of acted in. So we can see that acted in is an arrow pointing to the matrix. So we're going to recreate that arrow like this with the less than sign and then 2 dashes. So it makes an arrow like that. And then we're going to specify the name of the actor. So this is a person. So this person is in the movie. Okay? And if you do this arrow, it's going to return m, comma, in. It's going to return all the connections, right? So that's what we saw before. But we want to specify where this edge. So I'm going to take this out and show you. So you do less than 1 dash, open bracket, close bracket, dash. Okay, so it creates an arrow like that. And now you say what your relationship is. So we want to do the acted in relationship. So we're going to do R for relationship, acted in. And this is going to return only the names of the people that acted in the matrix. So if I run this, now we see only those acted in relationships. And it's really fast. So the perk of using Neo4j is you can traverse these edges really quickly and efficiently as data gets larger. So if you have millions and possibly even billions of nodes and edges, this is going to be a lot faster to query than if you use a relational database. Alright, so now that we see the picture, we still need to group to find the number of distinct people that acted in this movie. So if you press Control Up, it pulls up the query that we got here, and instead of returning the movie and the names of the people, we're going to say return the movie, movie.title, and then we're going to return the count distinct, so this is similar to SQL, count distinct in for the people as number of people, and press Control Enter, and we can see that the answer is 5. So 1, 2, 3, 4, 5. So we got the right answer. And then now let's say we want to return all the people that acted in all the movies in the database. Just take out this where clause. And so this will say, show me the movies that had the most number of people in this database. So match all the movies and all the people, return this information, and order by number of people descending. So show me the movies with the most number of actors first. And we run that, and we can see A Few Good Men has 12 people, Jerry Maguire has 9, 8, etc. So, so that's a quick way to kind of return all that information in a relational format. Okay, so now that we looked at this simplistic movie and person data set, let's practice loading in new data from the internet to explore some more nuanced examples. So if I go over here, we have a Sean Robinson demonstration. Sean is a former colleague of mine, and he's doing some really interesting graph work. And so this is pulling from something he published to GitHub, and it's a data set that's open source on Quora, which are different scholarly articles, and you can see that different articles are related to each other. Physics papers are related to other physics papers, but there's some overlap to computer science, right? And so Sean's pulling in a CSV file from this website, and so if you drop this website into your search bar, it comes up with all this crazy data, right? So what we want to do is I want to show you how you can take this information and put it into your Neo4j instance. So I'm going to say load CSV with headers from this URL and return star limit 5. So let's just look at the first 5 examples. So there's different features and different subjects and different IDs for each of these properties. So whenever you load data, you want to make sure that you set a unique constraint on any node properties, similar to a relational database where you would have an index, and you want the index to be as fast as possible. So we're going to create a constraint on papers. So that's the research paper. If the ID, so we want the ID to be unique, right? So we run this, and it quickly creates a unique constraint. And once that constraint is created, then we can load the CSV from that file, and this merge statement essentially will create a new node called paper with a property called ID from this URL. And the merge statement will check to see if that information already exists, and if not, it will create a new node. And then he's also setting some properties at the same time that he's creating that node. So if you just ran merge paper ID, you would create properties with that ID, but then he's also going to set some